All right, let's get it. So here is the problem that I gave you guys today. After looking at a few responses, let me share how I would do this problem. All right, first of all, shape. I think for the shape, you should describe that both functions are curves, and you would write this, obviously. Both functions are curves. However, I would say that the rational function, the green one, looks to be decreasing. I would say decreasing at a rate, while the square root function seems to be increasing at a decreasing rate. Okay. Table. Okay, so for a table, I literally want you to make a table. So the way you do it, if I've already given you h of x or g of x, you can do two things. You can just go to the cell and make it a table, right? But it really helps to see both functions side to side. So what I would do is I would go to a table once you've created a table, and go ahead and name a third column by the name of the other function, and that way you get all of these points, right? And that way you can see, well, there are certain points on the rational function that are greater than the points on the square root function. However, after 2, every point on the square root function is going to be greater than the rational function. Okay. Continuing, the fourth step was the domain. Domain, you actually have to write out an expression. So for domain, I would say something like, you need to specify which function you're talking about. So for h, let's see, what was the first one called? H of x, the rational function. For h of x, and there's a mean lag on my screen. For h of x, the domain is negative infinity to positive infinity, excluding x equals 0. That's because there's a vertical asymptote there. All right. Now for j of x, your domain is simply -2, and use a bracket right there, -2 to infinity. And that's because you can't use any number before -2. The function starts at -2. All right. For range, for h of x, again, the rational function, your range is going to be negative infinity to infinity, because it goes all the way to the bottom, all the way to the top, excluding y equals 0, all right, because there's a horizontal asymptote at y equals 0. And for j of x, your range is basically 0 to infinity, all right, because your lowest y value is 0, and your highest y value, well, it's infinity, all right. 0 is self-explanatory. The only one of these with a 0 is the square root function. It's got a 0 at -2, 0. It's actually its very first point. All right, so you would specify that right there. Y-intercepts, well, square root function has a y-intercept of 0, 1.4, while the rational function never has a y-intercept. Okay. Intersections, these functions intersect at 2, 2. End behavior, all right, the end behavior should actually be written like this. For h of x, which is the rational function, as x goes to negative, or I'm thinking math 3. The left side goes to 0. If you look at the left side, those values start getting closer and closer to 0. The right side goes to 0 as well. All right, and we're talking y equals 0. If you look at this, all these points get closer and closer to 0. Okay, and that's in behavior. Transformations. All right, so for transformations, we look at the numbers in our function. Let's see. How do I do that? For h of x, let's see. The 4 determines kind of a vertical stretch for the function. And for j of x, the +2 moves the square root function 2 units to the left. And that is basically everything that you need to write for this analysis.